Hi, this screencast is about calculating the average atomic mass. The average atomic mass is a weighted average of all the masses of all the different isotopes of a particular element. And we are able to calculate the atomic mass for any element by adding the protons and neutrons together. But because we have isotopes, there can be more than one different mass for any associated element. For instance, carbon can have carbon-12, it can have carbon-14. Most of the elements have multiple different isotopes and different masses. So what you need to do is you will need to find the weighted average or the relative atomic mass for the element, and that's what's reported on the periodic table. The standard that scientists use to compare the different atoms is based on carbon-12. So they have decided that carbon-12 will have a mass of 12 AMUs, or 12 atomic mass units. And so the atomic mass unit is 1/12 of carbon. So you can determine the atomic mass of any element by looking at the periodic table. The average atomic mass is, like I said, the weighted average of the atomic masses of the naturally occurring isotopes of the element. So calculating the average atomic mass will depend on how many isotopes you have. If you have 2 isotopes or 5 isotopes, you'd need to do all of what I'm about to show you for each one of those isotopes. So here's an example. If you were doing copper, and copper consists of 69.15% copper 63, which means it has a mass of 63 grams or AMUs, which its actual mass is 62.929601 AMU. And if you have 30.85% copper 65, which has an atomic mass of 64.927794. So you need to consider that there's more copper 63 around than there is copper 65, and you're going to do a weighted average. So how we do that is we take the abundance times the mass, and then we add up all the pieces for the different isotopes, and that gets you the average atomic mass. Alright, so what it says here in the second bullet, it says the average atomic mass of copper can be calculated by multiplying the atomic mass of each isotope by its relative abundance, expressed in decimal form, and adding the results. So, for instance, we had 69.15% of the copper 63. And we had 30.85% of the copper 64. So what you're going to do is you're going to change out of the percentages, and you're going to divide the percents by 100, and you have your portion of the 69.15% is now 0.6915, and our 30.85% divided by 100 would be 0.385. And you're going to multiply them by the masses that you were given. So the 69.15 gets multiplied by the 62.929601, and the 30.85% gets multiplied by the 64.927794, and you get masses, which you then add together, and that tells you that the average atomic mass of copper for the whole thing, the relative average atomic mass, is 63.545 AMU. So this is what is the naturally occurring average atomic mass of copper, and that's what's reported on the periodic table. So it's a couple of steps. You multiply the mass by the percentages of all the isotopes that you're given. It could be 2, it could be 10. Whatever number of isotopes you're given is what you do, and then you add them up, and that gives you the overall mass.